All right, we are going to look at defining and using probability. So one of like the key, or I guess the idea of probability kind of works something like this. If we had a number line, let's call these 0 and 1. We'll call this 1/2. What we would say is that if something has a 0 probability, or it's down here, it's towards this end. Again, if it's at 0, this is impossible. It cannot happen. Whereas if it's at 1, you are certain. You're 100% positive that it's going to happen. If it's 1/2, it's equally likely to occur or not to occur. And then if you just think about like the ranges, this would be an unlikely. It's still possible. This would be an unlikely probability, whereas something that's much closer to 1 would be much more likely to occur. So one word that we use is theoretical probability, which is basically what you expect to happen. So if I take this box or this set of numbers, say I've got these dots in here, and I drew a circle, the theoretical probability of drawing a dot out of this circle, if I count up all my dots, see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 total, and there's 4 in this dot, or in these dots. So theoretical probability works like you take the, so if you're trying to find the probability of A, and this purple circle is event A, you would take the number of outcomes on top and then divide it by total, so number of outcomes of A, and then total number of outcomes. So a classic one is like rolling a number cube, or also known as a dice. Find the probability of rolling a 5, and then the probability of getting an even number. Again, looking at a theoretical probability. Well, I know that there are 6 numbers on a dice, 1, 2, 3, 4, 5, 6, and 5 only occurs on one of them. So the probability of rolling a 5, there's one possible way, and the total number of outcomes is 6. Whereas if we look at rolling an even number, the even numbers on a dice, 2, 4, 6, I have 3 total outcomes of an even number with 6 total, which I could reduce to 1/2. All right, let's keep going. Another example. A community center hosts a talent contest for local musicians. On a given evening, 7 musicians are scheduled to perform. The order in which the musicians perform is randomly selected during the show. What is the probability that the musicians perform in alphabetical order by their last name? Assume that no musicians have the same two names, or the same last name. So if I think about a permutation, so again, permutation, order matters. So I'm going to say, all right, the order matters by their last name. So that means that there's going to be 7 times 6 times 5 times 4 times 3 times 2 times 1. There is going to be 7 factorial total number of possible ways to order this, but there's only one possible way that this is going to be in the correct alphabetical order. So if I were to figure out what 7 factorial is, again, that gives me 1 over 5,040, which is about 0.000198. So if we went back up here, I would say that this is a very unlikely possibility, but it's not impossible. Second part of this question, let's say you are friends with 4 of the musicians. What is the probability that the first 2 performers are your friends? So we have 4 out of the 7 musicians are our friends. So we're going to say 4, choose 2, put that on top, and I want to know, okay, those 2 occur first, but I am going to choose out of the 7 total. So again, thinking about how many different ways are there to do 4 to a combination of 2. There are 6, and the different ways, 7 combination 2 gives me 21. And if I divide by 3, I get, 2 7ths, which is approximately 0.286. So part B, much more likely than part A. We can use odds to measure the likelihood that an event will occur. Odds measure the chances in favor of an event occurring or the chances against an event occurring. So, again, kind of makes sense, but it's good to put these things, like just write them down. Very similar. If I'm looking for the event, I divide it by using the number of events, and if I'm not looking for the event, I divide it for times that it doesn't work. Which again, sometimes you might only have certain pieces of information. So, like to find how much it does not equal, you might take 1 minus whatever the odds of it happening were, and whatever's left gives you what you need. So let's say a card is drawn from a standard 52 deck of cards. Find the odds in favor of drawing a 10 and the odds against drawing a club. So if I think about a 52 deck of cards, there are 4 numbers that are the number 10. So the odds in favor of drawing a 10, and there are 48 non-numbered 10s. So again, if I think about that, I could divide this by 4 and get this equal to 1/12, or so the odds of drawing a 10 are 1 out of 12, whereas the odds of not drawing a club. So again, there are 4 different suits in a deck of cards: hearts, spades, clubs, and diamonds. So the odds of drawing a club, of not drawing a club, we have 3 suits that are not clubs and 1 suit that is. There are 13 cards, ace through king, in a suit. So 13 times 3 gives me 39 over 13, which again, 3 over 1 or 3 to 1. That's kind of working with some theoretical probability and just, again, determining what should happen. We also have something called experimental probability, which is what did happen. So you actually have to conduct experiments. You have to use them in order to find experimental probability. So again, if we're trying to look at it, how we would write it, this is the number of trials that actually occurred. Not what I expected, the number of trials that actually occurred versus the total number of trials. Or I guess this would be not number of trials, number of times trials where, like, the probability where A was selected. So the number of trials where A occurred. So let's do an example. Okay. Bar graph shows how old adults in a survey would choose to be if they could choose any age. Find the experimental probability that a randomly selected adult would prefer to be at least 40. So at least 40 means 40 to 49, 50 to 59, and 60 to 69. So again, how do we get our totals? We added up all of the totals of our bar graph, and we end up getting a total of 3,516. And then of those surveyed, of the three categories that we're looking at, we had 1,089. So the probability that someone chooses to be at least 40 years old gives us about 0.310, or about 31%. Okay. So want to get this picture in here. All right, so we're going to use this dartboard for our last example. You throw a dart at the square board showing your dart is equally likely to hit any point inside the board. Are you more likely to get 10 points or 0 points? So the probability of getting 10 points we have to figure out, and then we have to figure out the probability of getting 0 points, and then we're going to determine whether those are similar or not. So the probability of getting 10 is finding the area of the yellow circle, and then this is the whole area, and then the probability of getting a 0 is the area that's left over outside of the largest circle. So area outside largest, so again the blue circle, and then divided by the whole area one more time. So if I look at the circle, yellow circle, I know that the area of a circle is length times width times height. Mr. Larson. The area of a circle is pi r squared. So I need to find the radius. In this case, the radius is 3. So I'm going to do 3 squared times pi, and then my whole area is a rectangle, so it's going to be, the radius also goes this way. So let's see here. 369, my radius is 9, which means my height of my circle, my diameter is 18. So I'm going to do 18 times 18, which again is 18 squared. So if this is 9 pi over 18 times 18 is 324. You can simplify 9 over 324, and it just gives us pi over 36, which is about 0.0873. And then if I look at 0 points, okay, the area outside the circle, that's this area right here. So what I'm going to do is I'm going to take the area of the square, and I'm going to subtract it from the area of the largest circle, the blue circle. So the area of the square is 18 times 18, 324. And the area of the blue circle is my radius, 369. So my radius is going to be 9. So 9 squared pi. 9 squared pi is 81 pi, so 324 minus 81 pi. And my denominator really stays the same, 324. The whole area is 324. Now, this is going to give me, again, 324 and 81. We can simplify and get 4 minus pi over 324, which I get about 0.215. So if we compare our two probabilities, I would say that it's more likely that I get the area, or I get a score of 0, because my probability is higher than if I am looking to get an area of 10. or a score of 10. So because 0.215 is greater than 0.0873, we would say that the probability of getting a 0 is better, more likely